Hi, good morning and welcome. On the back of what we was discussing yesterday with quantum computers, I said that, it would be difficult for me if I was going to build one of these devices to connect the CPU to the actual quantum bridge. And I think I've come up with an opportunity of being able to do that. And this is how I'd do it. I'd remove an ordinary computer CPU off the main board, the intelligent board. So now we've got a CPU with hundreds of prongs underneath it. Now we've got to get every one of those prongs raised. First of all, we'll set it on, let's say, about a ½ meter standoff. Yeah. So we've got the CPU on a standoff about ½ meter or 50 centimeters off the main logic board where it sits normally. We're going to solder a wire from each prong on the CPU to the actual original point at where the CPU would have sat on the logic board. And then each one of those individual wires, once we've got that, well, what we'll do, we'll put the computer back on, just make sure we've got the CPU running still, to make sure we haven't made a mistake with any of the prongs underneath, because there is a lot, and make sure all our soldered joints are in the right places. So now we've got a CPU with hundreds of wires just going back down to the board, the logic board of the computer where the CPU sat originally. Each one of those wires we're going to take away slightly, pinch it away from the others, and we're going to wrap a coil around them. We're going to use that same technology as what we did remember the laser communication system that we built? How we got information going through the laser was by an induction method. And we're going to use that same induction method on each wire that goes back down to the logic board. We're going to wrap a coil around it, and then we're going to put that to a collector plate which comes in contact with the atmospheric air around us, which is also in contact with the ether. So then once we've reproduced that all the way around, I know this is sounding really complex, but it's just simplifying it really. I'm trying to put it in layman's terms so you guys can understand it. So now we've got hundreds of wires with hundreds of coils going round them, each wire, and we're connecting all those coils up to collector plates, which enables us to then interact with the ether. And then we're going to put the computer back on. We're going to download GDP on there, which is an artificial intelligence program, which is governed, it's got its limitations. And we're going to start asking it questions and see if the interaction bridge between the collector plates and the coils allow the quantum field to be bridged. Now, if we go back to the, understanding what was happening in that experiment that they conducted and proved and reproduced, what was happening is when they were firing electrons through the plate, it was under observation that they behaved differently. Or should I say the diffraction grating is what they fired it through. The wave pattern that was being formed changed only because it was being observed. So it proves that there is something else going on in our universe that we're only just coming to grips with in the last maybe 150 years or less. Or maybe there was other methods used in ancient civilizations to connect to the ether by using drugs or something like that. I mean, Malcolm McKenna said that by using these particular types of drugs, one of them was ayahuasca, you could connect with the nature around you, or as I think he described it as Mother Earth. So these things have been proven. It's just finding a way to bridge. Now, if you ask ChatGPT a question, it will come back with a regulated answer. If you connect that same program, the artificial intelligence program, up to a quantum computer and then ask it a question, you're going to get one of two answers. You're going to get the answer that the artificial regulated intelligence is going to tell you, or you're going to get the interacted version from the ether surroundings. And I think I've just explained how that is a very feasible and possible way of doing it. The collector plates are nothing special. They're just pieces of steel that come into ambient air around, each one. So you're going to end up with 100 of these plates connected with 100 coils that go around each wire of the processor, because it will be the processor that handles all the information. So we're just enabling, through induction, ether to connect to each wire on the CPU. Some of them wires on the CPU are just simple power on and off, and that it runs different applications of the computer, but it is the central processing unit on the computer that handles all the decision making. So any decisions that need to be made will be influenced by the ambient ether. I do have a computer which I could use as a guinea pig for this, but it would take an awful lot of time. And obviously, I don't think it would cost that much money, to be honest. I think with under £1,000 it could be done. And I'll just put this idea, the whole idea, on the back burner for another day. But the reason why I shared it with you is because why not share these great ideas with people like you? And if nothing else, you get an understanding of something else as well. So I think it's well worth sharing. That's why I've done this video today, and that's why I've done the video yesterday. I could have easily talked about exploding what they're called pages in Iran, just like hundreds of other YouTubers are talking about. But I'd rather talk about something like this, because it's at the art of technology and science, and that's what you guys really come here for, isn't it? I'm still waiting, guys, for you to get behind us here. We could pop the SD card out tomorrow morning if you wanted to find out the latest magnetic pole position. I'm just waiting for just a few people to chip in a few bucks. That's all. And we'll do it. Don't let yourselves down here. Don't lose something great like this observatory. I think we've done more for our subscribers than any other YouTube channel out there. I really do. Okay, links down there in the description. I'll say what I usually do. As always, bye for now.